Feel better. So we're going to use similar polygons today. Some of these words you've seen before. I want you to write here the symbol for similar. And I might have showed you this already, but we'll just write it down again. It's just a squiggly. That's the symbol for similar. We're going to talk about it right now. Okay?
I know what similar means.
So, if you have similar polygons, what that means is that the corresponding angles are congruent. Corresponding means what? They're in the same spot, position. Yeah, position. And corresponding, I'm going to abbreviate, corresponding side lengths are proportional, not congruent, proportional. Because we're talking about similar polygons today. They're not going to be exactly the same size, correct? All right. The scale factor of two similar polygons is the ratio of two corresponding sides. The ratio of two corresponding sides. All right. Let's work with this a little bit. In the diagram, triangle ABC is what? Similar to triangle DEF. If you see that symbol, remember that tells you that the angles are congruent, corresponding angles, I'm abbreviating here, and the sides are proportional. So you have to keep that in mind when they give you that symbol. Those are the ideas that you're working with. Proportional means you can set them up as a ratio. Like, I'll show you. Okay. Yeah, I'll show you. All right. So it says list all the pairs of congruent angles. So angle A and angle D, correct? There's one pair. I'm sure you could do this yourself. Angle B is congruent to what angle? And angle C is congruent to angle F. Now, shh. Hey. Check that the ratios of the corresponding side lengths are equal. We're checking that those side lengths are proportional or equal. Okay? So, what you do is you just set up, so AB corresponds with what side? DE. So I'm going to say 25 over 35, and I'm going to check if that is equal to 30 over 42. 30, 42. Yes? And I'm going to check if that's equal to 20 over 28. How can I check that? Reduce decimals or reduce the fractions, one or the other. Fractions is better for this because you pretty much will be working with that mostly. So I can divide both of these by what? 5. And I get 5/7, right? Is that, let's divide both of these by what? 6. Let's do 6 and we get 5/7. Divide both of these by what? 4. Would you look at that? So, the corresponding side lengths are proportional. Okay, that's what that means. Emma, get it? All right. Side lengths are proportional. All right. Write the ratios. Okay, this is important, Harry. Ready? Here we go. So, write the ratios of the corresponding side lengths in a statement of proportionality. All that is stating that they are equal. So the ratios, we would use the letters for that. We would say AB is to DE as BC is to EF as what? AC is to DF. You don't have to write the word as. I wrote the word as to show you that that's how you say it when you put the equals there, okay? Now, what did you notice I did there? I started with what? Each time, what's on top there? Always the same triangle, okay? So if you start with the small one, you keep the small one on top all the way across. Make sense? Okay. Statement of proportionality. You will have to write those sometimes. You'll also have to write statements of similarity, and we'll get to that. Alrighty. Determine whether the polygons are similar. If they are, write a similarity statement, which is just like a proportionality statement, and find the scale factor of RSTU to DEFG. Okay? So, what do we have to know to determine that they're similar? We have to know what? All their angles are what? Congruent. Do I notice the corresponding angles are all congruent here? Yes?
Yes.
Okie dokie. Corresponding angles are congruent. Check. Right? All right, now we have to check to see what? If the side lengths are proportional. So let's check that. So I'm going to start up on top here. I'll start with the big one this time. 30 to 20. Is that equal to, what would you do now? 12 to, okay. Is that equal to 33 over 22? And is that equal to 27 over 18? And when you reduce, this reduces to 3/2. This reduces to 3/2. This reduces to 3/2. And this reduces to 3/2. So yes, okay? Now, it says, find the scale factor of RSTU. So on the top of your fraction is going to be the bigger number, to DEFG. And that's how we did it, right? We set it up starting with the big triangle over the little triangle, correct? You see what I'm saying? This is RSTU over DEFG, isn't it? So we already have our scale factor. This number right here is our scale factor. That's our scale factor from RSTU to DEFG. I think we fill that in right here. So are they similar? Yes. The scale factor of RSTU to DEFG is 3/2. If that's true, then what's the scale factor if we're going from DEFG to RSTU? Right on, 2/3. Okay? How'd I get the scale factor again? It's just the ratio of the corresponding sides, right? That's it. Okay. All right. In this diagram, these triangles are similar. Find the value of x. All right. So if they're similar, I know I can set up a proportion with corresponding sides and solve for x. You kind of were doing that already yesterday. So you just choose a couple sides you can work with. It doesn't matter what direction you go. You just have to find x. So I'm going to start from here. I see I have 12 and 8, so I'm just going to do that. 12 is to 8 as x is to 16. One way to set it up. There's alternatives, whatever works, okay? So then when you cross multiply, I don't know what 12 times 16 is. I can't remember. Look how smart you guys are. Or quick fingers, one or the other.
24.
All right. And x equals 24, okay? Basically, if they're telling you they're similar, then you can use these proportions to solve side lengths, okay? All right, here we go. One more thing. Perimeters of similar polygons. Perimeters of similar polygons. If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. So think about what they're saying here. See, we have the ratio here, 3/2, right? That's the ratio of corresponding side lengths, correct? If I were to add all of these numbers up, the perimeter of this shape, and compare it to the perimeter of this shape, it would reduce to the same number, is what that's saying. Ratios are equal, okay? All right, so let's use that. You are constructing a rectangular play area. A playground is rectangular. Yeah, a playground, this is a separate playground. A playground is rectangular with length 25 meters and width 15. Oh, gosh darn it all, I just have to draw a picture. 15 by 25. That's my playground. The new play area will be similar in shape. That means it's similar, it's kind of the same shape, but only 10 meters in length. So I'm just going to draw a little smaller picture, maybe not to scale, but you know what I mean. Play area. All right. Find the scale factor of the new play area to the playground. So I'm going to start with the smaller, the play area number, right? Look, I have this corresponding side length here. And they're telling me that they're similar. So I can just write this ratio right now. 10 is to 25. And I got to reduce that. And I'll have the scale factor. Because the scale factor is the ratio of the side lengths. So reduce it. What is it?
2/5.
So there's my scale factor of from the new play area to the playground. Do you guys get that?
Yes.
Okay. Find the perimeter of the playground and the play area. Oh, okay. Well, do you remember how to find the perimeter of the playground? We know that this is 15 and this is 25, right? So if we add them all up, 2 times 15 plus 2 times 25 is equal to 80, right? That's the perimeter of the playground. Okay, the perimeter of the play area, I'm going to use this theorem right here. It says if two polygons are similar, the ratio of their perimeters is equal to the ratios of their corresponding side lengths. Oh, so I can use this ratio, 2/5. I'm using the ratio that we found for corresponding side lengths, and I'm setting it equal to a ratio for perimeter. Now, I don't know the perimeter of the smaller play area, do I? So that's my unknown, but I do know the perimeter of the playground, the bigger area. And then you cross multiply. X equals 32 meters. Yes.
So like to find the other, like the other side, well, do you need to?
Didn't need it. No, I didn't need it. I could have, but I just used the perimeter thing this time. Yeah, you could easily just do 10 is to 25 as x is to 15. You could do that. Okay? All right, almost done. Then hold on a second. Let me finish. Maybe you're done already. Okay. In the diagram, it's telling me that triangle MNP is similar to RST. Find the length of the altitude NL. All we have to do is we can just set up a proportion. So let's find a similar side lengths that we have the numbers to. What do we have the numbers to? We have 20 is to 30, right? Yeah? We could do that. This is proportional to this. So 20 is to 30 as what? 14 is to x. Cross multiply, x is equal to 21. Cool? All right, signing off.